We talk often about how important it would be to payment processing and credit card companies if they could help avoid even a fraction of the fraud that they face today. And I understand that, you at Aerospike, Tim, and you at Intel, Ginger, that you both partnered on a project with PayPal to help them avoid some of these losses. And I heard that they were actually saving about $1 billion a year in losses. So that is really exciting. Let me kick this off with you, Tim, if I can put you on the spot as our partner here at Aerospike. Share a little bit about Aerospike's hybrid memory architecture and how persistent memory is used in general, and then touch on why you recommend PMEM to your customers.
Perfect, thanks, Christy. So to paint a bit of background, because I'm aware that many people haven't heard of Aerospike, Aerospike is an incredibly fast NoSQL database. It's designed for the sort of challenges where people need a lot of data and they need it incredibly fast. To give you an example, we've got customers, they're one of the largest media and online entertainment businesses in America. They're looking at 3 to 4 petabytes of of data being stored in Aerospike. People typically use Aerospike in situations where they want to access that data in real time. So 99% sub-millisecond, and that's across any record. It's not, hey, I've got this set of data, it sits in memory. I want to access anything, any record in that, those petabytes or those terabytes in real time. And we have customers doing 20 million transactions a second quite happily. So if we look at the fraud detection space, the more data you can load in the same time quanta, the better. The more data you have, the better it is for your algorithms. So, PayPal, and we're working with many other fraud detection companies, credit card companies, and so on. The larger the data volume and the faster you can access it, the better. So Aerospike's designed to do that. And typically we'll store the information on SSDs, typically NVMe SSDs, Intel P4610s or similar sort of drives to get access to those data. The problem is when you have large amounts of data, you start having larger and larger clusters. It's better for a manageability purpose if you can cut the number of nodes down in the cluster, if you can reduce the size of the cluster. So imagine I've got a petabyte of business data. I need to replicate that data so that I can lose nodes and still not have any loss of data. Plus the database needs a bit of room to work. That's a lot of data. You're probably looking about 3 petabytes of storage. The problem is if I have a low density on my nodes, that's an awful lot of nodes. So Aerospike's unique architecture, the hybrid memory architecture you referenced, stores the information on the SSDs, but stores the indexes in DRAM typically. So when we go and look up a piece of data, we'll go and jump off from the client to the server that holds that piece of data. We'll look it up in memory and say, that's where that data lives, and go and read it off the SSD and return it. The problem is if we're using DRAM for that, I can reduce the number of nodes by increasing the size of my nodes. I can have lots of SSDs per node. I can have lots of DRAM per node. But I've got a customer who's looking at 80 terabytes per node in density. They have a lot of DRAM, but the problem is if they shut that node down, they have to patch their operating system or something like that. They lose that information that's stored in DRAM. When the node comes back up, it has to rebuild the information from the information on the SSD. And even with the speed of an NVMe SSD, it still takes a long time to rebuild out of 80 terabytes of data. So what we're finding is people really like these denser nodes. The ability to store the indexes in PMEM, and we use it in app direct mode. It's persistent, so that if they have to patch the operating system or the node crashes or something like that, when it comes back, the information still exists in PMEM. So the rebuild time drops dramatically. Instead of having to read 80 terabytes of data, it's just there in PMEM. And so we're finding more and more that people are getting more and more data. It's bigger data, they want it faster, but they can't afford for a node to be down and take an hour to rebuild its indexes as it comes up. They want it there in minutes or seconds. And so we're getting a lot of traction in these larger customers. People who have, say, 30 terabytes and up, they want small clusters. They want to be able to store the information in PMEM. And so we're seeing this in companies like credit card companies, in one of the leading brokerage houses in the US, who's looking at 400 terabytes of data. There's a lot of traction for storing large amounts of data and doing so in a handful of nodes. If I can store a petabyte of business data in 50 nodes, I can do that with these dense SSDs and Intel PMEM. I can't do that with DRAM in a practical fashion.
I have a quick question on that. At what point are you today where that starts to break down as far as where your bottleneck becomes the CPU on processing that data?
Aerospike's actually really, really light on CPU. So we are a key value database. We typically, bottlenecks typically tend to be the network, and it tends to be the IOPS on the drive. Sometimes if we're doing compression at rest or encryption in flight, there's some CPU, but it's incredibly rare for us to be bottlenecked on CPU. And the performance we see out of PMEM versus DRAM, to Aerospike, it's negligible. We get most of our bottlenecks reading it off the SSD or writing to the SSD. So we love the PMEM. It's larger, it's cheaper, it's byte addressable, and it's persistent. It's great for us.
Wow, we could just stop there. No, so can you bring us down now to when it was time to start working with PayPal? Why did ultimately they select both Aerospike and persistent memory in general? How did that go?
So that's actually a two-part question, because they moved to Aerospike from an existing legacy platform that was a couple of relational databases and a huge cache, 350 nodes odds of cache in front of it. And in their first phase, they used Aerospike without using persistent memory. This was a good number of years ago, and persistent memory didn't exist at that point. So they took that very large deployment and moved it down to 20 nodes of Aerospike. They had two different relational databases. One was read-only, one was write-only, because they found that you couldn't get read and write performance in the same node. Oh, wow. Now, their original drop dropped down to 20 nodes of Aerospike, and that replaced both relational database and the big cache in front of it, and the same cluster for reads and writes. The second step of their journey was looking at using PMEM. Now, 20 nodes was big. They found that their original data volume in the relational system, they had more than 10 times that amount of data in Aerospike. The more data in fraud, the better. And so they moved into that. And then using PMEM, they want to compress those 20 nodes down further and drop down to, it's about 10 nodes, but they're much more dense nodes. I think they're looking at about 4 times the storage density per node. And this enables them to store more copies of the data. In the old system, they were storing 2 copies. Now they're looking at storing 3 copies, and have more data that's there for their analytics to run on.
Now, is there ever a concern of now your blast radius is, if something happens to one of the systems, it's really high and they've gone from huge numbers of nodes down to a few?
There's always a trade-off. As you drop the number of nodes, the cost of losing a node is higher. You've got a smaller number of copies of data of some of your data, and you've got to move that data around to behind the scenes to end up with the right number of copies of the data. Now, Aerospike does that transparently, and it doesn't in the background. But yes, there's a performance cost. That's why they're increasing the number of copies of data from 2 to 3, so that they could lose multiple nodes simultaneously and still have the right number of copies of data.
Interesting. Okay. All right. Thanks for sharing that. And Ginger, you were on the Intel team that was working with Aerospike and with PayPal. Were there any unique challenges, or tell us a little bit about the proof of concept time that they did? Yeah.
Right. Absolutely. So like Tim mentioned, PayPal chose PMEM for 2 main reasons. One being that infrastructure consolidation, going from 20 nodes down to 10. It's a huge hardware savings, and they calculated that it's a 30% hardware cost reduction, which is fantastic. And then the other side of that is the operational efficiency, in that now you have a 10 node cluster that can be brought down. Each node can be brought down and brought back up very quickly. So you can do a full cluster upgrade in an afternoon instead of multiple days like you would before. So I think as far as the benefits go, PayPal recognized those right away. And then the one area that they really needed to work with was to make sure that this new hardware didn't hurt performance in any significant way. So they, like Tim mentioned, they need a lot of data and they need it very quickly, and they can't sacrifice too much of that speed and latency. So kudos to Aerospike for working on their code to really reduce as many of the barriers to performance as they could. And then also our technology works really well. And so PayPal's POC showed, just like we saw in our own testing, there's very little performance difference by adding that PMEM. And then again, even increasing the density of each node, they were a little bit worried that that might cause some bottlenecks, but that didn't seem to be the problem either. So once they saw the POC, saw that performance is consistently good, and saw the great TCO savings and operational efficiencies that they could do with this PMEM solution, I think they were sold.
That's really good to hear. Are there any unique considerations at a customer like PayPal because of the data security, regulatory, hardware encryption? I mean, were there any unique factors that you guys had to keep in mind for this customer?
One of the ones I would point to is the scale of the customer. Because they're doing fraud detection, that they want these clusters at the edge. They want it very close to the users, because if you're transmitting it across the country, you've got a very, very tight window where you say, yes, it's fraud, or no, it's not. So you want these clusters close to where people are doing the transactions. Therefore, their clusters are very dense, but they have lots and lots of clusters around the world. And so they want to make sure it's the right technology. Their proof of concept was, it gave great results, but they're very cautious. They want to make sure they've got the right results, and that they're not going to just suddenly throw out their old clusters and replace them all with these PMEM-enabled clusters, because there's simply too many of them around the world. So it's a big scale challenge to do the rollout. I think from all the conversations I've had with PayPal, they're very, very happy with the combination of Aerospike and Intel and the PMEM, and the resiliency they get out of it. But in terms of features, the privacy and stuff like that, it's the normal sort of challenges you'd face in a financial institution. The ability to support encryption at rest and encryption in flight gives you the ability to secure that data, and that's all taken care of by the database. Okay,
great. Well, that one's really interesting. I spent a lot of time in my early years of my career working with financial customers, so I'm always fascinated by the work that they do. Mm-hmm. So Ginger, is there anything else that you found compelling that I'm just basically anything else that you want to say or share about the experience?
Sure. So let me just, I guess, clarify and make sure that we understand. PayPal is using persistent memory to store the index for their data, and their data is being stored on SSD, but now Aerospike also does allow you to store your data in persistent memory. So while PayPal's not using that right now, I did want to mention that that's definitely an additional benefit you can get if you use Aerospike, and performance on persistent memory compared to SSD is a performance benefit, whereas moving the index from DRAM to persistent memory is not a performance benefit. So I just wanted to add that.
Okay.
And if I can elaborate on that a little bit more, one area we're seeing Optane on the memory bus for storing data having a great benefit is in financial services. You want to ensure that your data is written to the drive. So when Aerospike acknowledges a write, by default, it'll put it into a memory buffer on multiple machines, and they'll be flushed to the drive asynchronously. In financial services, that's often not good enough. You want those writes to be flushed to the device synchronously. So by the time you come back to the client and say, yes, I've got it, even if the entire cluster crashes simultaneously, you're not going to have any chance of losing a write. So SSDs don't necessarily give us that capability. You can do it. You can force a commit to device, but there's a big performance penalty of doing so. We've seen up to a 50 times performance degradation on doing so. Storing the information in PMEM, because of its byte addressable and its unique characteristic, that performance penalty of doing a commit to device drops to almost zero. So for financial traffic, which really, really cares and has to be absolutely accurate all the time, that offers a big advantage.
Oh, that's really interesting. Yeah, I hadn't thought through that. And so you're saying PayPal did not take advantage of that in this case, or they did?
No, that they have not. They're keeping their indexes in the PMEM,
right,
but their data is on typical volumes. And the sheer volume of their data is a challenge trying to store it in an Optane DIMM or even on the Optane devices.
Right. So maybe they would be the ones that would be excited if we had a 1 terabyte DIMM stick.
It's entirely possible. I don't want to speak for them, but yeah, there's a number of customers where bigger is better.
Right.
Yes, yes. Okay. Great. Well, thank you guys for sharing that story. Are there any questions from the delegates?
I have a question. How long did it take for you to refactor your code to move the indexes to PMEM?
Yeah, so I did work with Aerospike's engineers on the refactoring the code for the index specifically. It was really a matter of, instead of allocating memory in the Linux shared memory, it's setting up to allocate memory into the persistent memory. And then once you've allocated that memory, it worked really well with Aerospike's existing APIs as far as updating elements on the index. So we didn't have to do much during runtime. It just runs with the normal Aerospike code. And then at shutdown time is again where we had to go in and explicitly flush all of the caches to make sure that there weren't any, nothing was left in the cache. But it really, for the indexes specifically, it didn't take long. I think we were up and running with a prototype within weeks, and then, just refining from there.
So another question: what's the advantage? Obviously, of persistent is key to PMEM, but the capacity also is an increase. What's, from a customer perspective, like PayPal, is it the persistence of the metadata warm start capabilities that make the most difference to them, or is it the fact that they've got more of that metadata that they can put into quote unquote memory and consolidate the servers accordingly?
From what I see, it's a combination of both, and it depends on the customer. Some customers really like the warm start, and the way Aerospike works, every index is always a fixed size. It's always 64 bytes. So we can work out, based on the number of records you're storing, how much pressure there is on DRAM. And if you've got larger objects, if my average object is, say, 10 kilobytes, the ratio of my 64 bytes for my index to the 10 kilobytes means that I'm typically not pressured on the size of memory. Other customers want to store smaller objects, and then you start getting more pressure on the amount of DRAM. And so the larger size on PMEM had some capabilities there. And the fact we can get up to 6 terabytes on a 2-socket server. So it really comes down to the use case. Everyone likes the warm start capabilities, but whether they like the extra size or not really is use case dependent.
I think the challenge with the warm start from a PMEM technology perspective is that this requires changes to the logic of what's going on at shutdown, the logic that's going on with at the startup and stuff like that. Whereas the capacity increase seems to be fairly straightforward and easy to utilize. I don't know. It's just my opinion.
Mm-hmm. Yeah, I'd agree with that. And there's definitely customers who have said, that if we can get more DRAM on a box, then it's useful. Even if they don't have the large data volumes we're talking about. And so they might consider PMEM for its higher density, not necessarily its app direct persistence mode. That we do encounter that situation. It's more rare than saying, yes, I really want my indexes in PMEM for that shutdown and restart time. But the changes are all encapsulated in the Aerospike database. So from the application perspective, people don't care. It's a simple configuration switch which says, yes, I'm storing my indexes in PMEM, and all the heavy lifting and making sure it's the warm start and the app direct mode is set up properly is all done for them.
I got it. Thanks.
And Ray, when I was talking about our learning journey and how we realized how important the software ecosystem is, this is exactly it, because we're changing the way you can't just pop it in and use extra DRAM if you want to take advantage of these other features. And so, our dependence is on making sure that our ISV partners are aligned with us and that we're working in concert, can't be overstated.